Materials supplied by Microsoft Corporation may be used for internal review, analysis, or research only. Any editing, reproduction, publication, rebroadcast, public showing, internet, or public display is forbidden and may violate copyright law.
So we are ready to start. And again, this panel is can industry and academic collaborations be effective? And we are going to have some starting comments from the panelists, and then we will open the floor for questions. And Josep would like to do some thoughts, and he prepared some slides. So let's start with Josep.
Thank you. So this is going to be very brief. So the first thing is, depending on what type of collaboration are we talking about, right? There's many degrees of collaboration. There is a small collaboration that occurs with a student intern working on a site, to a medium degree of collaboration where you have one faculty and a couple of students working remotely, or to a large environment where you have a large team of faculty. And I think the problems occur the more you go down, right? The earlier part is easy, you know, except there are some issues on who controls the student, but the problem occurs down as you move down here, right? And especially when you have one faculty, each of them contributing 1/100th of your time. So
that's definitely a problem.
The main difficulty here is that there is a basic disconnect, right? The faculty wants to perform novel research, wants to work on long-term issues, while the sponsor, many times, he or she is worried about IP issues, is worried about deliverables, and many times they want to work on shorter-term issues that are not compatible with longer-term issues. Of course, we tend to gravitate to this thing all the time because we all get something out of this. For the faculty, it gets extraordinarily rewarding if you have the ability to contribute to the sponsor's work. Of course, there's the danger of wasting your time and resources, students, doing an interesting and unpublishable work. On the sponsor side, it's also very rewarding, could be, because folks from your company can gain good knowledge and interact with faculty and students. It may turn out into a waste of time, loss of control, unable to set the agenda, and so forth. So I've seen it many times, okay? So I can tell you that I've seen this with the DARPA PCA project with IBM, with DARPA HPCS project with IBM, which I was part of as well, UPCRC, I2PC with Intel and Microsoft, DARPA UHPC with Intel as well, and DOEX stack with Intel. So I can perhaps offer a couple of hints of what works and what doesn't work. Okay? So what works is that if we have clear goals as we get into the big project, people know and trust each other on both sides. It works best if you know your colleague in industry because of same area and you work with them for a while, perhaps 10 years ago or 20 years ago. It helps if you have a clear definition of the work of each of the academic PIs. So each of the 10 faculty or 3 faculty or 4 faculty has to have a distinct role, in my opinion. It works best. It's best if we agree that the IP issues will not be in the way. And it works if you have periodic calls, weekly calls, and physical meetings, even if it looks like a waste of time. Kind of deep dives every 2 weeks on topics and so forth. And also, of course, it works if academics have a clear value added to the project. If they don't, then it's not good. So these are the good things. The bad things that will make it fail, I think, is if the sponsor contact person changes often, that's a very bad thing. So if we get somebody from a certain company and every 6 months we have another person, that's not going to work. If influential people in the company are against the collaboration, of course, and you hear this right away from the beginning. If the start is an arranged marriage by the government or other entity, it's not going to work either. So oftentimes you have DARPA projects where you need to have a token academic or some other person, then it's not going to work. If you have unclear partitioning between the faculty PIs, then it's not going to work. People are going to stump on each other. Nothing will get done. And also, of course, there's always the issue of personalities, which you cannot predict from the beginning. So I think for this to work, we have to emphasize the things that make it work and try to avoid the stuff that doesn't work. Thanks.
So, who would like to follow that from the panel?
Well, sure. I disagree with a lot of those things, I guess. I think academics are lousy at doing work in the short term. I think we're the wrong place to go. We can't deliver on schedules and stuff like that. So I don't think we've ever done anything that we didn't think was a long-term research with industry. I mean, people come to us and offer us money to do things, but I tell them, you know, we're just the wrong place to do that. The way we do these projects is to get, we even use the phrase 2 feet in, is that I'm really not interested in leading a project with 100 faculty spending 1/100th of their time on it. We want to have a group of people who are signed up, who are committed to the goals of the project, and to do that you need to get significant funding for those faculty, so at least half of their students are on it. And if you don't, then it's, you know, it's pushing string, right? If you're trying to run around and get faculty, you know, their fraction of a graduate student to get them to pretend they're working on a thing, it's really hard. I agree about the personalities. You know, we try and put people together who can work together, and, you know, and there are certainly colleagues who always have worked independently at Berkeley and probably always will. You know, that wouldn't be your first choice to put on to a team. But, you know, I don't, you know, the tether era at DARPA was one that I was pretty much on public record of making clear my disapproval, and they turned academic researchers into kind of consultants, right? There would be, the academics were, I don't know, window dressing or something. And so I'm sure that was I'm sure there was a lot of bad relationships, you know, awkward circumstances. But I don't think of UPC as, you know, I don't think the relationships we've had with industry have been like that. I think one of the things I liked about it was surprising about being industrial funded versus DARPA funding was kind of the program managers were so much better. You know, it was people who you went to conferences with who were the people you interacted with and gave you feedback. What we, you know, we're closer to Silicon Valley than Illinois, but we don't do weekly phone calls. You know, the thing that, you know, if every time you bump into me, ask me what's the most important thing, I'm going to say retreats. You know, we do these 3-day intensive things, invite lots of people there and give us a lot of feedback on what's going on. You know, I guess if it was a joint project split between Berkeley and some company and there were groups working simultaneously on it, we'd do something every you know, regular meetings. But I don't see why that would be necessary, you know, in the way we do these things. So
Burton hasn't.
Yeah, I agree with Dave. I think I've had, you know, lots of university collaborations over the years. I used to be a university person, and then I became an industrial person. And all my collaborations have been about long-term topics. All of my collaborations have involved, well, the only mention of IP is that if we invent something together, I at least would like to have the ability to use it.
Yeah.
Either because it's publicly available and not, you know, protected in any way, or I have a nerf from the university or something. But that's really all that I want.
Absolutely, industry doesn't want to fund it and not be able to use it.
Yeah, that's right. But it needs to be long term, and it typically is something where the university has at least, or the person has at least half the say and maybe 3/4 about what the subject is. It just has to be interesting enough for the agenda of the company I'm working for. So, for example, when the edict came down in HPCS from Tony Tether that, you know, that we weren't going to be funding academic institutions with HPCS funding, and Bob Graybill came around and said, okay, but you've got to pick up some faculty because, you know, industry has to take on this role. I said, fine. And so I recruited Bill Dally and Peter Kogi and people like that. And guess what they worked on? They worked on 10-year problems, mostly, that I knew were going to be biting us eventually, but weren't biting us right now. And they knew it too, and they were interested in these things. So the whole PIM stuff that Peter was pursuing for our HPCS proposal was very much long-term stuff. and pretty bleeding edge, I think. I think it's safe to say. And you know, we wound up not doing it because of management decisions, I guess I would say. But it was definitely longer term stuff, and we shouldn't be cooperating with universities just try to use them as a labor force or something like that. By the same token, I think this idea of being able to transfer technology immediately from academia into industry is just broken. I mean, it's not the way it works, and so we shouldn't be asking for that either.
You mean in that DARPA?
Yeah,
stuff,
or
right?
anybody else. I mean, we shouldn't just sort of say, well, you know, a particular collaboration with the university is valuable to the extent that it allows us to transfer the technology developed or the ideas developed in that collaboration directly into product. I don't think that's realistic either.
You know, I feel bad here because I usually say that there's nothing worse than a panel where everyone sits and says, well, I agree with you. It makes for a boring panel, so I guess we're going to have a boring panel. But I did want to bring one angle, because I too have been involved with many, many collaborations over the years, and I have found one truism over and over and over again. If the industry people put people in joint projects where the industry person's monthly status report includes that collaboration, if they're not going to put that much skin in the game, they just shouldn't do the collaboration, period. You know? And that's, to me, if I were managing, you know, projects at my company with universities, it would only be long-term, yes, absolutely, but it would also be, okay, who's putting the skin in the game in terms of committing their time to work directly on projects with the faculty. And if you don't do that, then it's just the industry throwing money away so they can say that they're working with this university, but they're not likely to be happy with the outcome.
So let me change the subject a little bit. So I think given the sort of composition of the audience, it might be worth talking a little bit about why companies fund this type of work. And there isn't a simple answer to that. And I think part of the problems with the centers have been that people have assumed that there's a simple answer, and they've interpreted things that have happened in terms of their perception of what the companies should have been doing when it put the money into it. You know, the obvious answer is that we love research and we love giving money to the best people in the field, and we feel good because they publish lots of papers and advance the state of the art. You know, that's not high on the list of most companies' decisions to spend money. You know, there can certainly be a belief that it's good to advance the state of the art because everybody benefits from it. But companies generally are not looking out for the general good. They're looking out for their own particular good. And in particular, in this case, Microsoft and Intel had some very specific goals in mind when they got the UPCRC centers started. You know, we wanted to revitalize parallel computing research, which, you know, I think we were probably pretty successful in it. Whether it would have happened or not without us, I don't know. I mean, some of it certainly would have. I think we wanted to shift the focus of research away from the scientific, large-scale HPC to other domains, and I'd certainly say we were successful in this case, and somewhat in the larger community, and I don't think that would have happened without us. You know, we obviously want to train good people even more than we want to see papers published because we hire good people, and I think that certainly happened in both schools, and so there's a lot of good there. You know, tech transfer, I don't think anybody really realistically, you know, I'm not speaking for Intel, I'm speaking for Microsoft. I don't think any of us realistically expected anything to come out of either project that we could pick up. There just isn't a history of that inside Microsoft. The code that's produced in universities is not commercial code. The ideas certainly can be brought in, but they're typically brought in by hiring the people and having them come to the company rather than, you know, reading the paper or picking up the code or buying something like that. And, you know, it's way too early to tell. Tech transfer takes years. I mean, even for people with inside Microsoft, like me, who have a blue badge, who sort of sit here, it takes a long time and it's very hard to do tech transfer. And so the expectation that sort of a new research project that was producing results for most of 5 years and at the end of 5 years would have tech transfers to show for it, I think is unrealistic. And everybody knew that when we got started. And there's probably there were lots of other motivations that were going on. So, it's not simple to say why, we decided to fund 2 parallel computing research centers. And I think that a lot of the misunderstandings were that people sort of picked one of those reasons and they said, that's why you guys did it. And you're doing this action that doesn't conform to that particular motivation. And that caused a lot of misunderstandings over the years. So just keep that in mind when you're working with industry, is that it's not as simple as going to the government where there's just a funding source where the law says you're giving out money for this reason.
So David Pado has a comment, and I'd like to use your microphone. I hope it's on.
Yes, 2 comments. Obviously, you are right, and I think the main reason is that Microsoft is not a thing. It's a collection of entities interacting with each other. And when you go to the reasons why things happen in an institution, you can look at the institution as a black box, and then it seems like it has a mind of its own. Or you can go deeper, and then you will see that the outcome is the result of many forces. And that's probably what you are trying to say. There are different interests, different people who think in different ways. And I think what you said is absolutely right, that those objectives, the ones you mentioned, seem totally reasonable. I am sure there are others that has to do with internal politics that we will never know. So it's but to me, in terms of articulating why this is done, I think, again, you're right. It seems to me that the function of corporations in sponsoring research is similar to DARPA rather than the National Science Foundation. So DARPA has a specific objectives. They put funding in that, and that shifts the emphasis of research in a certain direction. And that is good and bad. So if DARPA has the right vision, they can steer the research community in the right direction. When they err in the direction, they can waste immense amount of resources, as they did with high-performance Fortran, for example. So in that sense, question that I would have is, was this emphasis a good direction? Is parallel computing in the client side, which is what we were asked to do research on, was a worthwhile direction for us to embark on, or that is something that is not really going to flourish?
So
is that a question?
Yeah, right. Well, I think it's an interesting question, and I think there are 2 answers to it. 5 years ago when we started, that seemed to be a direction that was extremely important to both companies. And that was a large part of the impetus for us to get together and fund this research and to do the other things that I talked about. That was the best guess at that time. With 5 years more hindsight, I would say no, that the world has progressed just fine without significant parallelism on the desktop. I see some interesting applications coming out that might change that, but right now it hasn't changed that.
I think we found a disagreement.
We sure did.
Okay, so it's good. I'm just throwing that out there.
Yeah.
But at the time we made that decision to fund it, I think there was a pretty broad consensus across both companies that yes, it was important.
Yeah, I'd like to add. So I think since we had to, thanks to the change in DARPA leadership, I had to figure out how to do industrial funding immediately. And nothing that Jim said surprised me. I just think everybody, not just the academics, but industry too, should appreciate I agree with what you said. We can talk about the things that we can evaluate in the short term, which was getting people's attention to work on parallelism. That happened. Focusing on the client, that was a really big change, right? And that was a very different shift.
Yep.
And and we brought we brought those apps to, like Hotbar and stuff like that. That was a very different set of apps with different set of requirements. So those things we can evaluate. Technology transfer takes time. So I have heard people who are not in academics who have already evaluated the project without giving the time to see if technology transfer is going to happen. And, I would like more people to appreciate what you said, right? It's too early to say about the technology transfer piece and evaluate, the success so far. The other thing that happens with companies is kind of with universities, once we get a bunch of students together and head off in a direction, we can't change as the companies, if things change for the company over the, one graduate student lifetime. If the company says, well, parallelism and desktop, that's not it. It's NUI interfaces. We can't just shift all our people and, make them work on the thing now. We get set off on it's like a rocket ship. We're heading towards this destination. We can't change our direction, and succeed in the education part. And yeah, it was really interesting to me in the industrial fuzzing is you wanted the students as much as you wanted the ideas. So that was really clear. So I think, are we going to produce great students? Have we? Yeah. Did we help get people focused on parallelism? Absolutely, and on client side. So we did all the things that people wanted us to do 5 years ago. I think of us as hitting the bullseye, right? And it's just a little frustrating now for people to claim either maybe that wasn't the bullseye, or, we know you didn't hit it, right? Well, the parts we can evaluate, I think we hit. The parts about how significant the impact, it takes years to figure out the answer to that. We should get to the right thing to do, and I actually do this. I do reunions, right? I bring people together years later and we'll look back. This is 2012. 2017, 2020, we'll look back and see what happened at both companies, right? That's when we'll be able to know that. So, one of the reasons this come up is, so did this one work, right? Well, the parts we can measure worked. It's hard, and we can guess how successful the technology transfer is, but.
Are you going to organize a reunion for us in 2017? Is that? I
tend to do that. I was on this big committee on campus, and I said I'd do the reunion. Everybody said, sure you will. And then 5 years later, I held the reunion. Yeah, I think it's healthy. It's I believe in feedback, right? How are we going to know, how are the students, how are the faculty, how are we going to know how this worked? Really, we should get together in 5 or 7 years.
I've been to 2 of the reunions from the project I worked on for Dave. Yeah. And the only depressing part of it is you come back and you look older.
Yeah.
Yes. If we could do like a cosmetic surgery day or something.
But I want to weigh in on something here. Though. I've over the years been involved from actually both sides, as an academic and in industry. And I just have to say personally, this interaction with the Berkeley folks in UPCRC has been the most satisfying and successful academic industrial collaboration I have ever been involved with. And I think if you're not from UC Berkeley, it's worthwhile exploring why it was so successful. And I'll say why it was successful. I already mentioned 1, there were people from Intel, myself included, who put skin in the game. 2, the concept of bringing all the graduate students and faculty into one physical space, getting most of the faculty to sit with the graduate students, that succeeded beyond my wildest dreams. That was amazing. And what it meant was when I visited, I didn't have to keep track of, oh, this professor down that hall and this professor on that floor. No, they were all in one space. And then the retreats model, the fact that twice a year we all got on one place, including folks from all the periphery involved sponsors, all came together in one place and shared ideas. I just have to say that that's a model that other universities should study very closely and try to replicate, because it really, really worked.
So I should say, Jim, I think Intel would disagree with what you said, that it was not a good idea. A lot of the tools and things that they have been developing, right, have some input from the group at Illinois, at least.
No, I didn't say it wasn't a good idea. I think David's question was the focus on desktop parallelism the right choice?
Well,
and
well,
the answer,
that's what I'm saying.
I've got another problem with that, and that is it was on client parallelism, and in fact,
client parallelism, yeah.
Micro, yeah, and in fact, mobile.
The clients
stuff
changed in the middle of it.
Well,
yeah, but from the beginning
no.
we talked about the
not in so it wasn't desktop parallelism in Berkeley's case, and I don't think it specifically was in Illinois either. I mean, I don't recall.
And so Intel probably has a slightly different opinion on this, I think.
I'm sure, and they're certainly welcome to their opinion. No, he did.
So we have
did.
mics in case you want.
Oh, I did. Fear not.
I don't think anybody else has slides.
I think that's the first time anybody's ever said
Okay,
that
so
to
Robert is
Burton.
coming.
Defend Burton's opportunity to talk.
Wow, I never had that happen.
I have a question for Dave, and the point of that is,
Somehow that mic.
Turn it on.
and I won't use it.
Then speak loud.
Much better.
Yeah.
So first, I agree with Tim on what worked and why, and especially the retreats, because I didn't go to Berkeley as often as he did, but I did go to the retreats, and those worked really well. And both in terms of what we learned there, and in terms of opportunity to give feedback. And we actually saw, at least I did, that in the next time things were modified according to our feedback.
It's not just pretend.
So the question is really a small detail, but just to improve my understanding of the methodology, you mentioned that you didn't want to have weekly phone meetings, and why is that? What's the downside of those?
Well, I think Josep said, I interpreted his slide saying a necessary condition for success was weekly phone meetings, and I think that's one way. But that's not the only way. I think.
Okay, so you're not saying that they're evil. You're just saying they're not mandatory.
No, I don't think it's a bad idea. It just takes that's a tremendous. It's a
lot of
harder
time.
commitment to get out of faculty and students and people in industry. If every one of our sub projects needed to have a weekly phone call from somebody at Intel, Microsoft, that would have been a hard thing.
But
to follow.
that's what we do at our companies. You saying that's not a good idea?
So that's
I'm just telling you, these are people taking classes and teaching classes, and often different time zones, and so that's a hard thing to do. So,
doesn't mean
so that's
the
why that's why we like the retreats where we suck you all there for a very intensive, whatever that is, 48 or 56 hours, and we get a lot of interaction.
So you have a comment,
Yeah.
Sarah?
So I guess I've kind of collaborated a lot with both companies over the years, and I wanted to add to what Tim Mattson said I think that for me it felt like part of the reason that the collaborations could be so successful in some cases is that it did feel like in the case of Microsoft and Intel and our major sponsors that they were all in and they were going to be around for 5 years. And so as far as collaborations go, it felt like on either side we didn't have to have short-term thinking. Like Intel definitely helped me in cases where maybe right away it wasn't going to help them, but because they believe in the project long-term. And I think we've also tried to step out and give them things that help them in the short term, because you kind of know that everyone's around for the long haul and that you really want the whole thing to succeed together. And in the case of more affiliate sponsors, it never felt like that, because people were coming and going, and you didn't know if they were going to be at this retreat or the next retreat. And so I think the mindset from the beginning of we're all going to kind of normalize with these retreats so we get on the same page, and then you're going to be around for a while, like really helped the collaboration and kind of maybe allowed us to take bigger risk than I think you would if you just found a collaborator and we're talking about doing a short-term project and maybe we'll publish this paper in 6 months or something. So at least I thought that was maybe different than I felt other collaborations be, and I think that kind of made it really neat.
Also, Leo wants to make a comment.
So I agree with a lot of what Sarah said, but I want to actually kind of expand what we mean by text transfer. So I think right now a lot of what we talked about was, will my particular code go into this particular project? And like a lot of us did try this, and sometimes it's hard, getting into a browser and shipping to 100 million people.
That's hard.
There are certain challenges with that, especially when you don't know what hardware they have. But there's a really remarkable discussion actually we had with Sarah and a bunch of other people in this room at the last retreat, where we're trying to say, what type of demo should we do for the final Parlab? And then pretty much we went around the table, and each person proposed a startup that was enabled by the technologies that we developed in our lab. And that's a very different type of tech transfer. This is almost like opening markets. But this is types of things that we couldn't do on our phones before. I think Gerald's talked today about, now we could do million-song real-time stuff on your phone, essentially. You couldn't do that before. I don't care what company you're transferring that into, but that's an entire class of product we were seriously discussing what type of fun games we can make, and just and the goal was could we make those games in a week?
But wait a second, Leo. It's quite reasonable to say the tech transfer doesn't have to go to Microsoft or Intel, but the amount of effort that it would take you to go and do the startup and the number of years it would take for that to actually roll out as a product, is very significant. It's not like, just sitting around the table saying we could do a startup with this idea has affected anything. It's the same. To actually see the impact, you actually have to form a company, turn it into a product, sell it, and everything else like that. And that's a lot of work too. It's probably not that different than actually sort of seeing some of those ideas being put into a product from one of the companies.
Actually, we were talking about actually potentially doing like just apps for phones, which are actually supposed to be generally the life cycle is roughly a weekend to 2 weekends.
Yeah, but how you can always put software out on the web. I mean, there's billions of software projects out there, but how much impact do they have?
So for us, tech transfer doesn't mean transfer of code. Even if we have research reside inside the company, inside Intel labs, that are applicable for the compiler, let's say, we're not going to take their code because they're not going to adhere to our coding conventions, etc. So we're going to take the idea and re-implement it. And at that level, we can do here. So the big idea is that we want programmers to write patterns, and we want system software to turn that into something efficient and well parallelized. And that idea we can take. And we were not going to take code anyway. Now, that is going to work very differently for a whole number of reasons. And so to synthesize that idea and make it something that fits into our stack needs a lot of thinking. But it's an idea that's worth pursuing. And that's one of the things that we talked mostly about in all the feedbacks, right? How do we capitalize on SIGITs? And not necessarily by forcing our existing customer to write Python code.
So some of the software devices that we developed at Illinois make it to prototypes at Intel. And that, I think, is tech transfer right there. So in the example I gave of deterministic replay, there was this FPGA design that they have. The operating system all came from Illinois, how you monitor the system or you manage the buffers and so on. That's something that is getting into the labs, of course. It's not getting inside Intel development. But I think it's possible, in a couple of years.
Well, and that's a great example. And you had an Intel researcher from PSL directly collaborating with you on that project. And so it's, he tied his research agenda inside the lab to that collaboration. And that kind of brings buy-in and gets a good transfer of ideas. So that was, in my restricted view, one of the biggest successes out of the Illinois collaboration.
But my guess is that the executives who are trying to evaluate was UPCRC worth it, are looking for something, where the main product line changed in some significantly positive way. And like I said, I mean, if we do a reunion, I think we'll be able to look back and see, will we be able to see that or not, right? That's one or both of these companies. That's probably the way they think of it.
Yeah, I have no idea since I'm not one of those executives.
Well, I don't know. I mean, I think how about it this way? If that happens, I think probably they will say success. Maybe if it doesn't happen, they'll still say it was successful.
Yeah.
But,
Yeah, next time I'm talking with Paul Ottolini, I'll ask him about that.
Yeah.
We get together to kayak all the time.
I don't know that Paul Ottolini knows about this project.
Probably better.
What was that?
He knows this.
He does know. Okay.
So the audience, if you have questions, please, we have some microphones. Robert has one.
What time does the last bus leave? I have a microphone so I can ask a question, right?
Right.
5:30, right?
There's a 5:30 bus.
There's a 5:30 bus for those who want to leave.
Okay.
Right.
There's a dinner?
It's either food or shelter.
There's a dinner here tonight?
Receptionist.
Oh, there's a hard choice.
I didn't know that.
It's in a separate. It's part of tomorrow's agenda.
Oh, I didn't know there was a dinner.
To come here tomorrow.
So I wasn't a Microsoft employee when this started, but as an external observer of this process in another institution, I felt like the community was not ready for parallel computing. We didn't have enough graduate students trained in parallel computing. We didn't have enough undergraduate education. Intel made a big push for parallel programming classes and parallelism in the curriculum, and that a key that that we needed. You need people who understand parallelism in order for all this to work, and that this infusion should have generated a bunch of well-trained people who understand parallelism and could do something, even if their exact project wasn't a success. And like you could say, one of Dave's early projects that produced Jim Larus, his particular thesis work was not a success, but Jim is a success, right?
We were just 20 years too early.
Yeah.
We were building multi-core workstations
we were ahead of our
before
time.
the term was coined.
Yeah.
We'd
only invented multi-core.
So for people who were putting the money together, I think a really important thing, if you're going to do the 5-year reunion, is who was in these projects, what companies are they in, and did that happen? And so you could be altruistic and say, we're also a success if somebody else got leverage out of these people. And then you could have your selfish success be, we hired people from these projects and they impacted our company. And so then you could have the more altruistic version of success, and then you could have the self-absorbed version of success too.
So Catherine, there was a little of that at the beginnings of the program when Craig Mundy and Justin Ratner deputized me and Andrew Chen to go try to rustle up money to do this. The motivation was, in part at least, trying to energize the academic community on the subject. And call it altruism if you want. We both think we're pretty important companies in the computer business, though. And what's good for the computer business is good for U.S. Steel, or what is it?
No, U.S. Steel is good for the USA. What was good for the computer industry was probably good for Intel and Microsoft.
Exactly.
Yeah.
No, I just wanted to say, Catherine reminded me of something. As I reflect on my career, I've been on 10 of these big projects, or 11. 3 of them have been parallelism. The very first one I worked on when I got to Berkeley, I thought they wanted me to work on parallelism. That was not a very good project. I learned how to do projects from that. The one with Jim, the Spur project, and this one. So what's different about this one? The educational impact is different. You know, Randy Katz and I taught the 3rd semester course in architecture, and we saw it, and we just couldn't teach it. You know, it had been not changed a lot in the last 5 or 10 years. And so now it's thoroughly parallelism, right? So what do? These 3rd semester students, they do MapReduced, and use warehouse scale computing and MapReduce. They do SIMD parallelism in x86 instruction set. They do thread level parallelism, and these are sophomores, right? and at the end, the ones who are really enthusiastic, they do matrix multiply, the first assignment in Jim's graduate parallel class. And the best of them outperform the Intel Math Library. These are sophomores. So I mean, it was like, well, I think what we tried to do is aim for the top half of the class rather than worrying about how little the bottom half wouldn't what's the minimum they would get. And but I was very impressed with them. And also, wow, this time we're really teaching it, right? And it's not just lip service. It's it's mainstream. Kurt Kortzer did a class. Kathy Yellick did a class. So I think parallelism is now part of the curriculum, and that's the first time that's been true. And that's once we get into the curriculum, then it's big numbers of people that are being trained this way.
Can I ask a question?
So
if you were to go now and try to get funding for parallelism from Microsoft and Intel, do you think you will be as successful as you were then?
At the moment, I don't know.
Why not?
The tough economic times have had some impact on everybody.
I think I don't know. You should leave out I don't. I think the focus is different. I think Intel, suppose you talked about energy efficiency.
Yeah, but but parallelism, a big part of why parallelism is so critical is energy efficiency.
So I wouldn't rule it out.
I wouldn't rule it out at Intel, even though I'm not in a position
I don't know
to
at Microsoft where that is in the, where's the crisis, right, at Microsoft? I wouldn't, if you called it parallelism, I don't think
parallelism is the crisis, and I don't think energy efficiency is the crisis.
I think it makes sense for Intel, and I don't think that's the issue at Microsoft.
So for sure you have to change the keywords from project to project, otherwise it's not going to work, right? So that's, I think, the reason.
I guess to me, I know the name of Parlab is parallelism, but when I look back and think of what the big contributions are, it's not necessarily that we, you know, parallelism was a theme that we kind of worked with, but the things we made aren't just, you know, parallelism related. And it seems like almost every research project going forward in the next lab, or every research project is continuing in either, you know, Aspire or one of our other labs. And so it sort of seems that maybe the answer is yes, people would fund it, you know, going again, because we didn't just solve parallelism, we did different things. So maybe we need to rebrand the lab or something for legacy. But it seems that, at least to me,
No,
it
the
seems
lab
that
is the
we ended
physical
up being
space.
relevant.
It's, the physical space is called the PAR Lab. The next project will have a different name.
Yeah, I'm just
It
saying
won't
that
have PAR in the
it's
name.
not like we're stopping this research. Almost everything
No,
we
right.
have noticed is very valuable going
Right.
forward. So it would be strange to
And
say,
that's
oh,
what I
we
mean
wouldn't
when
fund
she-
it
Yeah.
again.
Yeah, I
Yeah, but it, yeah,
I
but
think I agree
it
with
wouldn't
what
be
you're
called
saying, but I want
parallelism.
to add that I firmly believe no matter what happens next, parallelism will be a key part of it. Even if
Yeah.
the name doesn't say parallelism,
right.
there'll be parallelism underneath. And in many regards, that's success. That's kind of what we wanted to do, is to make
Yeah.
it routine that just, of course it's parallel. Why would you be stupid enough to do it serial?
Right.
Well, that's dumb.
Yeah, if we proposed a follow-on project that was not parallel because it's not cool now, I don't think that would get funded.
No.
So, for example, if you look at the DARPA perfect thing, right? So after the parallelism, they went into this very low power thing. Parallelism is there as the bullet, a very important bullet.
It's not low power. It's high energy efficiency. Very different.
Yeah,
So-
very
Yeah.
different.
But nevertheless, right.
So
No, but I agree. Parallelism,
you find parallelism there. all
parallelism
over
is
the place.
obvious. Obviously, you wouldn't do something that wasn't parallel, right? So
Yeah.
Well,
kind of progress.
that's the outcome you'd like, yeah. Yep.
It's a good point to stop.
Do we have more questions from the audience? Do you have any other?
No, this is boring. We're agreeing too much, so.
That was disappointing, wasn't it?
Was it enough money?
Was it enough?
Yes. Yeah. Yeah. It was, we got matching
Send
money
back
from the
whatever you
state.
haven't spent, Dave.
Yeah, I mean, well, how many academics are ever going to say that? It was plenty of money. It was $2 million, and we got matching funds from the state of California before it went bankrupt.
Was it enough for you? Was it enough for the community?
Oh, I can't.
We didn't fund
I
the,
don't
we
know.
didn't fund the
I don't know how to
candidate.
answer that
No,
question.
no.
I don't know how to answer that question.
It's a driven increase in 2 institutions. So now you guys supposedly don't ask for as much DARPA or NSF money, so it frees up more money. And was there enough is there enough
Was enough money
parallel
invested in
research
parallelism?
the last
No.
Is that the
5,
question?
10 years?
If there was
No.
enough, you know, like I said, I
Heck
think I'm
no.
pretty clear on the record that DARPA money was not well invested for one whole presidential administration by the longest-serving DARPA director. I feel comfortable defending that. Suppose that money hadn't been given to extremely wealthy companies, hundreds of millions of dollars to extremely wealthy companies. I don't know what NVIDIA and all those guys are getting. You know, they get support for their next product development. You know, Sun, IBM. Yeah, I mean, maybe Cray was a smaller company that did it, but why did IBM need money from hundreds of millions of dollars from DARPA to work on computer architecture, right?
I've been,
Yeah, well, you know, suppose that money had been invested in universities on parallelism in 2000, which is what the original idea. Suppose that money suppose 1/4 of that money had been plowed in universities to work on parallelism in 2000 instead of whatever, like 2004 or 5 when we got, you know, emergency started. This decade it might have been very different.
Yeah.
I've been complaining to NSF in particular, but other agencies as well, about very poor support for systems work, by which I mean architecture, compilers, operating systems, and in general, the infrastructure of computing. And parallelism and distributed computing, maybe even worse at the moment, are very important emerging requirements in systems that are not being addressed by the academic community to solve these long-term problems, precisely because systems research involves fairly serious amounts of money and people and projects and so on. And NSF has lost the taste for funding that, as DARPA had and maybe still does, I don't know. So that's a really serious problem.
The other thing, Catherine, is that this project was deliberately not designed to fund the community. I mean, it was very explicit that originally it was only going to be one school, and then it was expanded to 2. And it was not intended to fund parallel computing in universities in general. There are lots of lots of
Intel and Microsoft forked over
well, we wouldn't have done that funding model. But I think lots of other universities were able to take the evidence that this was important enough to Microsoft and Intel and go to the government and say, you should be funding our research because it's important to companies that are important.
So I think it was very exciting to have this big chunk of money. So for the 2 universities, it was very good. I feel that we lost an opportunity to excite the rest of the funding agencies to join in.
I agree.
So, you can see that there hasn't been like another kind of push. There was SRC, semiconductor, partnered with NSF to have this program on multi-cores, right? But NSF didn't come up with a big program. DARPA didn't come up with a big program, right?
No, they had a huge program. They just gave it all to industry.
Yeah, yeah.
Hundreds of, how much was invested? When I criticized Tony Taylor, he'd said, look at how much I'm investing in industry. Hey, look how much money I'm spending on this. It's just not, in universities.
True. That's true. But they wanted to see the follow-up from DOE or NSF or DARPA with big chunks of money to many universities. That we didn't see.
Yeah, Fred Johnson had a FastOS project when he was at Energy Research, but he's one of the few government funding sources historically that actually funded universities doing systems work.
I remember there was a time when you guys, maybe some of you went to Washington to speak with NSF people.
Yeah, like me. I talked to Rita Colwell about it. I talked to Arden Babette about it. I talked to Jeanette Wing about it. I talked to Regina Boxey about it. I talked to just about everybody who would listen to NSF.
So that was the time to come up with NSF programs that could match these things.
They didn't do it, though.
It may happen still.
So one measure of success that I'm looking for is when do you think our customers will start writing parallel code?
They already are.
The advantage I have working on the Intel compiler over, let's say, working on a Microsoft compiler is I know all of my customers with middle name and mother's maiden name, and they're not.
And they're not yet writing parallel code?
Some of them starting, but I can't say we crossed the hump.
This is why I assert that this is not a finished problem, that there's a lot more work to be done. And that it concerns me when I hear companies that should know better suggesting that it is a problem that's not critical and doesn't need a lot more attention. It concerns me.
It may take another decade for ISVs to kind of catch up with this.
Well, the other thing to remember is that if you have a large, important software piece of software, it doesn't change very fast. So, Microsoft introduced a language, C#, well over a decade ago, which is clearly an improvement over C and C++. And, for the longest time, I would get questions to people like, are you rewriting all your software in C#? And, that's sort of a nonsensical question.
It is.
Because the answer is no, you're not going to rewrite it in C and C#. Just because the costs are huge and the compatibility issues are huge. I think parallelism is at least as radical a change in the architecture of software as it is moving to a managed language. And it's going to be gradual, and it's going to happen at a slower rate. The new stuff can pick it up faster because it starts smaller, and it can be architected the right way from the first. But the big companies with the big important pieces of software are going to be slower.
I guess the frame of reference is which companies you consider big and important. And by the way, size is not your friend, right? So clearly big companies don't change their software infrastructure often, but
when I said big, I meant big software.
Right. We have data showing that that actually is in the context of adoption of Windows 8. And the target market for that is spending 38% of their time on new applications, first-generation applications, and 37% on less than 5-year-old. So this is not your HPC crowd, right, that keep fixing bugs in the existing software all the time.
So another thing is, in my opinion, this is my opinion, a lot of companies are distracted with the cloud computing now, porting their codes to the cloud and all the rearrangements that require to their code, hoping that they'll get better and faster. But eventually, maybe they'll find that it's not the way to get the stuff faster, and they need the speed, and then they will have to deal with parallelism. That's an optimistic view.
What you mean? So their apps don't have a parallelism that will take advantage of the cloud? Is that what you think?
Yeah, exactly. So they will find that if they want the speed, there is the need to parallelize. I mean, I know many companies now that they are reorganizing the software for the cloud. So,
but I think they're doing that for economic advantages
That's
that
right,
aren't performance advantages.
but so they're distracting, or they're focused on this at this point, I think.
Yeah.
What's the new software deployment and economic model? And if you miss it, you're going to be in trouble, right? That's driving industry.
The other part is mobile. I mean, neither Intel nor Microsoft has as big a visibility into mobile space as they would like, right? So that's a polite way of putting it, right?
Yes, very well done. Good job for a future director.
But that will change.
You wish you were even more successful.
Maybe missing what's happening in that space in terms of app development. Yeah, that's all new code, right?
It's all new code, but the platform is not
very
parallel yet.
Yeah.
And I think you could argue that it will be, but it's not there yet. And part of it is a chicken and egg problem.
Yeah, but that would be that's part of the let's wait 5 years argument, right?
I know, but,
yeah.
but if you wait 5 years, all these sort of new apps are going to be the legacy apps there.
Yeah. Well, I guess that'll be.
Some of them are going to be.
I only take bets when they're sure things, but there'd be some kind of bet about, in 5 years, will the apps that are being developed for the mobile devices, be explicitly parallel, right? That'd be the.
Depending on how you quibble over the definition of explicitly parallel, I think they will be.
Yeah.
And once again, it's power. It's all power. Heterogeneous, parallel,
That's what
mobile
I
platforms.
assume if we did a vote, we would think that would be true. And so, yeah.
Oh, no, I know it will be true.
I think there'll be
We can resolve the bet right
applications.
now.
I think there'll be applications of parallelism in mobile devices to support user interfaces, and they'll also have multiple service requests outstanding at the same time to various web services to deliver whatever it is they're supposed to deliver.
So there'll be concurrent apps internal to which there are parallel apps. And it's all going to have to fit together. And those of you doing research in fundamental technologies for underlying parallelism and concurrent applications are in no danger of running out of work.
You're not going to run out of work. That's right.
Yeah, well, it would be really, would they embrace some of the ideas that both the schools have talked about, like patterns and, will they do all that? I mean, I'm not saying.
In my completely unbiased opinion, yeah, sure, they're going to. It's all going to be biased.
No, but it'll be which of the ideas that seem incredibly vital now to make progress will be embraced, over the time. It'll be fun to watch.
Yeah, it will be fun to watch.
So it's 5:32. Thank you very much.
All right.
Thank you very much, everybody.
Yep. Thank you.